Alright, so this video is going to be about writing and solving proportions with questions that are all about rates. Now, we've had a video that was devoted on just how to solve proportions in general. So if you're given the proportion, what can you do to solve it? And we learned the cross product property is always what you'll use to solve any kind of proportion. Sure, there's some slightly faster ways. There's some ways that might be a little bit faster for certain kinds of proportions, but they don't always work for all proportions. So our main focus is going to be what works for all proportions, and it really doesn't take that much time. So we're talking about the cross product property. So that's what we've used to solve proportions. What we're going to talk about in this video is how to write your own proportions. I consider that a separate skill all on its own. Is once you know how to solve them, every single time it's exactly the same. Cross multiply and get a one-step equation, get the variable by itself. But what's going to happen though is, what if you didn't know how to write that proportion to begin with for yourself? What if it was a word problem, such as the few we're going to do? We're going to go through some examples, and we're going to work them through and see if we can write our own proportion and then solve it. So as you go through this video, take the time to hit pause and try each of these questions on your own and see if you can come up with the correct proportion and see and solve your proportion for the missing value and see if it gives you a reasonable answer. And then press play and give yourself some feedback. See if you're doing it. Because remember, you always want to practice with purpose, especially when you're confused about a topic. Always practice knowing you can find out right away if you're doing it correctly or not. Alright, so let's see. We're going to focus on today writing the proportions. We'll still solve them, but our main focus is going to be on writing them. That's what we're going to pay the most attention to. So when you write proportions, the tip I gave you in class and the tip I'll remind you of now. When you write proportions, so when you write rate proportions, you could probably write this down. When you write rate proportions, because we can use proportions for many situations. We're only going to focus on rates right now. When you write rate proportions. So now I'm referring to questions where there's a rate. Like look at number one. There's a rate. We got to figure out what is the rate per egg. That's a rate. So when you write rate proportions, you should always line up the units of measure. Now you know you have a rate proportion. Usually what's really obvious is the units of measure will be different. So line up the units of measure. For example, if your question's all about, let's say, temperature rising over a certain amount of time, like let's say in 3 hours the temperature rose 2 degrees. That gives you a rate. That means every 3 hours it goes up 2 degrees. But what I want you to know is if you were to solve a proportion using that information, you have to be consistent. So if a proportion is a fraction equals a fraction, or a ratio in the form of a fraction equals a ratio, I want you to be consistent. So what I mean by that is this. You can choose to do time over temperature on one side of the ratio. I'll just call it temp for space. Equals, if the left side is going to be time over temperature, the right side must also be time over temperature. So if that's going to be time over temperature, this side's got to be time over temperature. Now, if you chose to flip it, when you were writing your proportion, if you chose you want a temperature to be on top, fine, but temperature would be on top for both sides, so this side and this side. You have to be consistent. Line up your units of measure. So temperature, let's say time was in hours and temperature was in degrees, you would have your hours up top and your degrees on the bottom, or degrees on top on both of them, on both sides, and then hours on bottom. As long as you're consistent, that's the key. So let's use that to help us with number one, okay? Now for all these questions, let's assume the situations are proportional, write and solve a proportion, and if necessary, round to the nearest tenth, which by the way, hint, that's 1 digit after the decimal. So let's take a look at number one. Number one is all about cooking. It says, Everardo paid $1.12 for a dozen eggs. So that gives us some information. $1.12, that's a number. Dozen, that means 12. It says determine the cost of 3 eggs. Alright, so here's what we're going to do. They gave us a rate. $1.12 for a dozen eggs, or sometimes the words might use the word per, P-E-R. $1.12 per dozen eggs. So that is a rate. You can write that one of two ways. You could write it as $1.12 over 12. So $1.12 over 12 eggs. I'll even write eggs down there. So we can see our units of measure. On top it's dollars, it's money, and on the bottom it's eggs. That's our unit of measure. Now on the right side, we gotta have a fraction equals a fraction. Next time I'll use a different color so it doesn't blend in so well. Let's see, this one says, determine the cost of 3 eggs. So we have 2 blanks. One of them is gotta be the 3 eggs. You ask yourself, is it this one or is it this one? You only have one choice. Because you put eggs on the bottom on this side, we just said you had to line up your units of measure. So eggs must also be on the bottom of this side, of the right side. So that's going to be 3 eggs going right here. So writing the units of measure is a great way to help yourself remember to line them up. We don't know how much that's going to cost. I'm just going to put X. X is going to represent the cost of 3 eggs. That's what we've got to solve for. So we have our proportion now, to where we now have a situation where we know it's $1.12 for 12 eggs, and then we want to know how much is it, because cost is on top and number of eggs on the bottom for 3 eggs. If we solve this proportion, we will have our answer. Now remember, I know you can do these, I know some of these are pretty answers you can do mentally. So, but I want to give you a process that works even when the numbers aren't pretty, to where you can even consider doing it mentally. So we're going to use the cross product property. So as a reminder, you multiply both directions diagonally. So we'll multiply this way. And the direction you choose to go in does not matter. Remember that. The direction you choose to multiply in does not matter. So we'll multiply one way then the other. So the first direction gives us 12 times x. And then the second direction gives us 1.12 times 3. Those are the 2 directions we've got to multiply in. So let's work on the left side. 12 times x, don't overthink it, 12x. Now 1.12 times 3, well 3 times 1 is 3, 3 times 10 is 30, 3 times 2 is 6, so that gives us a grand total of 336. So 336. Now if you're not sure, feel free to do your long multiplication off to the side, and just be careful with your multiplying. So that gives you 336. Now, it occurs to me on the left side, I forgot the x. So remember, 12 times x is 12x. Do not erase the variable, because the variable is what we're looking for. So if you erase it, you're not looking for anything. So you've got a one-step equation now. You got to get x by itself, so you got to move 12 away from x, move it to the other side. We learned back in chapter 3 how to move coefficients to the other side. When they're touching like that, that means multiply, and so to move it, you have to undo it. You have to do the inverse, or the opposite of multiply by 12. So the opposite of that is going to be divide by 12. So you're going to divide by 12 on both sides of the equation. They're going to cancel on the left. So on the left, you're going to be left with x. I'll just switch to black. You'll be left with x. Now on the right, we got to figure out what is 336 divided by 12. That's what we've got to figure out. Now, many of you, most of you are like me. I don't know what that is off the top of my head. I'm sure I can figure it out mentally and try to work it out. But let's also make sure we have a way that always works. So off to the side, I'm going to go do our long division. So I'm going to say dividing by 12, dividing into 3.36. Let's do long division. So let's see. 12 does not go into 3, so that's a 0. Now remember that the decimals always go straight up. So now 12 into 33. 12 goes into 33 2 times. 2 times 12 is 24. Subtract. Gives us a remainder of 9. Now just to be sure, yep, gives us 9. Now you drop down your 6. The 6 came from right there. Now 12 goes into 96. Let's see. I know that 12 goes into 60. So I'm trying to figure out how many times 12 goes into 96. I'm thinking maybe 7 times. Let's see. 12 times 7. That's what you can ask yourself. 12 times 7. 7 times 10 is 70. 7 times 2 is 14. 70 plus 14, that's only 84. So that's not going to be the 96. So we'll try 8 times, because we have room for maybe one more. 12 times 8, so that's 10 times 8 is 80. And then 8 times 2 is going to give us 16. 80 and 16, they give us 96. So it turns out that's how many times 12 goes into 96. And it does it evenly with no remainder. So look what we have. We have 0.28. X represented money. So if you have 0.28, that tells you money-wise, that means for 3 eggs, it is 28 cents for 3 eggs. That's you answering the question in the context of the problem. So that's your final answer to this question. To answer it, it is 28 cents for 3 eggs. You've answered it. So to recap, when you wrote your proportion, you know that it's dollars on top, eggs on bottom, and it's completely okay if you wrote yours this way. If you wrote yours as, let's say, 12 eggs on top over $1.12. Now, when you go to write the other half, you have to be consistent. So you got to have 3 eggs on top, since eggs are on top, and then you can just put X on bottom. So even if you wrote yours this way, that is completely fine, and that will still solve exactly the same way. Because look, you're still going to cross multiply 1.12 times 3. Well, hey, that's what we already did over here. And then you're going to end up having to divide by 12, since that's who's left over here, because it'll be 12 times X. So you'll have exactly this line, even though it looks different. So remember, when you start the proportion, you have choices. I don't care if you do eggs on top, money on bottom, or vice versa. It also doesn't matter if you have these backwards. Let's say you had these the other way around. What if the left side said 3 eggs over X? Or if it said X over 3 eggs? It does not matter, as long the left and right doesn't matter, but who's on top does matter, to the point to where you have to make sure that you are consistent. So I'm going to erase that one out of the way so it doesn't clutter us. That way you only have to pick one. So as long as you're consistent and you line up your units of measure, you are good to go as far as writing your proportion is concerned. So we'll get those stuck on there. Still thinking. All right, so that's going to be example 1. We found out how much it was for 3 eggs. So just focus on lining up your rates of your units of measure. These are for rate proportions. So let's take a look at number 2. We'll scroll down and get past that one. Now, number 2, it's something completely different. The last one was about eggs, shopping, groceries. This one's about traveling. So let's read this one. We'll go a little bit faster now that we kind of remembered line up your units of measure. You're traveling. A certain vehicle can travel 483 miles on 14 gallons. Okay, thank you for that information. So that actually gives us a rate of gasoline, by the way. So determine how many gallons of gasoline this vehicle will need to travel 600 miles. So we have a rate. We have how many miles for these gallons. That's a rate. Now, most people like to think of this as miles per gallon. That's one of those rates they're used to hearing. So out of that habit, I'm going to go ahead and put miles on top and gallons on bottom, especially because that's the order they gave it to us. But mostly because we're used to thinking of it as miles per gallon and not gallons per mile. So I'm going to go ahead and write that proportion, and I said to use a different color. So we'll do that in red. So we have 483 miles over 14 gallons. That's our rate. That is a rate. And the best part is the rate will always be half of your proportion. The rate will always be half of the proportion. So that's great news. That tells us if you can identify the rate in what the given information, you're already halfway done with writing your proportion. Now just pay attention to which unit measures on top and bottom. We have miles on top, gallons on bottom. Or think of it as distance on top and then fuel used on bottom. All right, so let's see. The question says, determine how many gallons of gasoline this vehicle will need to travel 600 miles. It just asks us how many gallons of gasoline. So that means what's missing is going to be gallons of gasoline. Since we know gallons is on bottom, we're going to be looking for how many gallons of gasoline. It's got to still be on bottom. So we'll put X down there. Any letter you want, doesn't matter. Now up top, it says 600 miles. Since we have miles on top, we must still have miles on top on this side. So that is a proportion that we can write and solve to answer this question. When you're working through these, when you're writing your proportions, remember, like I said earlier, it's okay if you flip top and bottom as long as you do it to both sides. If you want to have gallons over miles, that's fine, but you have to be consistent. If you're going to have gallons over miles, you must do it on both sides. We chose miles over gallons. If you have these entire things switched, that is perfectly fine as long as you are being consistent with who's on top and who's on bottom. That makes a huge difference because if you have them backwards, you'll get an answer that doesn't make sense. So we have a proportion. We're going to solve it using the cross product property, same thing as we always use. So we're going to multiply this direction. So that's going to be 14 times 600. That's going to equal the other direction, So x times 483, x times 483. So we're going to simplify, and we'll have a one-step equation. All right, so now on the right side, that's the easy one. So x times 483, don't overthink it. 483 is now the coefficient of x. And now on the left side, 14 times 600. It sounds like a really big calculation, sounds a little scary, but you know what? We can do it. What we're going to do is we're going to work out, we're like, okay, what's a shortcut we can use? Rather than 14 times 600, 600 is pretty big, we can do 14 times 6 and then just add 2 zeros to the end of it. So that's what we're going to do. So we're going to do 14 times 6. That's what we'll actually check on the side. I'll do it over here. So 14 times 6, let's see what that equals. 6 times 4 is 24, carry the 2. 6 times 1 is 6, plus 2 is 8. So 6 times 14 is 84. And we said we're just going to put on 2 zeros on the end of it. So, okay, so that tells us 84 with 2 zeros. So 8,400 is what that tells us. Now, I did it again this time. I forgot my x. Please don't make the mistake I keep making. 483 times x is 483x. So let's see. We have a one-step equation. We have 483x equals 8,400. Our job is to just get x all by itself. So that's what we're going to do. So to get x by itself, we have to divide both sides by the coefficient to get it by itself. So divide by 483, because that's how you get rid of all coefficients. Don't forget, when a coefficient's touching a variable, when they're touching like this, that means multiply. The opposite of that is divide. So divide both sides by 483. They cancel on the right side. We're left with x on the right side. Now on the left side, our job is to figure out what is 8,400 divided by 483. That's a tall order, but we'll take our time, we'll count, and we'll take it step by step, and we'll figure it out. So long division, we're dividing by 483. We're dividing into 8,400. The decimal's after the zeros, so the decimal goes straight up, goes right there. Right off the bat, we know 483 does not go into 8. 483 does not go into 84. 483 does go into 840. So that's going to be the first thing we got to figure out. Alright, so these great big giant numbers, I'll admit I cheated just now. I hit pause and went ahead and worked it out to make sure there's long division. So take your time with these, and with giant numbers, it's on tests and quizzes, of course, I'm not going to give you a long division problem that you got to spend forever to do, but don't be afraid to do it. And when you're at home, you're welcome to always double check yourself with a calculator. Alright, so let's see. We already started going through. 483 goes into 840. It goes into 840 one time. Alright, so then 1 times 483 is 483. Once again, some of these numbers, if you're not sure where I'm getting them from, take the time to go ahead and go back and hit pause and check them with the calculator if you want to, that's fine. But for the sake of time, I don't want to sit there, I don't want to explain how I got some of these. So 483, so we subtract out, we get 357. Drop the 0 that you have right there. We're going to drop that 0. So we have 3570. Now 43 goes into that 7 times. So now 7 times 483 is going to give us 3,381. Subtract that, we get 189. Now drop another 0 from out here. Drop another 0. All right, so 483 goes into 1,890 3 times. 3 times 483 puts us at 1,449. 1,449. All right, subtract those. We're gonna get 441. And now we gotta drop down another 0, and we gotta see how many times does 483 go into that. 483 goes into that 9 times. 9 times 483 gives us 4,347. Wow, this is really exciting. I don't blame you that this is not the most fun thing in the world to do. So now, at that point, you really don't need to keep going. So I apologize if the last 15 seconds was atrocious of me doing long division. So just remember though, it said round to the nearest tenth. At this point, we have 2 digits. The second digit, that's enough to tell us. That 9 tells us to round up the 3, round it up to a 4. So that's where we're going to get 17.4 from. We're going to get 17.4. Now remember, What that tells us, 17.4, that was the missing number of gallons. So to answer this question fully, we will say 17.4 gallons of gas. So 600 miles will take that much. So 600 miles will take 17.4 gallons of gas. That's the conclusion we came through with solving our proportion. So write your proportion by lining up your rates, and now use the cross product property. Remember to hit pause anytime we go to a new question to try it first on your own, at least to see the first part to make sure you wrote the proportion correctly, because that's the skill we're focusing on right now. So number 3, it's all about illness. So it says for every person who actually has the flu, there are 6 people who have the flu-like symptoms. So resulting from a cold. The flu-like symptoms resulting from a cold. If a doctor sees 40 patients, determine how many of these you would expect to have a cold. They told you for every person. That means they're referring to one, for every one person. So that means for every one person who actually has the flu, there are 6 people who have had flu-like symptoms. So that gives you a rate. That tells you 1 and 6. Those are the 2 numbers. So we're going to label that as 1, I'll call it flu, one person who actually has the flu, for every 6 people who just have a cold. So for every 6 people that have a cold, that have flu-like symptoms, for every one person that actually has a flu, there's 6 people who only actually had a cold. So that's what that tells us. So we would love to charge forward and be like, okay, we have our rate, that's half of our proportion. And I'm already going to tell you now, we're going to have a problem, because take a look. It says, if a doctor sees 40 patients, did they tell us how many people had the flu or had cold-like symptoms? They didn't tell us either. Because they didn't tell us either, that means we can't use our rate, because we don't have a flu number or a cold number. We just have a total number. We have a total number, 40 patients. So what we're going to do is, we're going to be like, okay, how can we rephrase the rate we have and think of it as a total number? So now, ask yourself, how many people are we talking about total? We've got 1 person with the flu, 6 people who only had a cold. How many people is that total? You're like, okay, that's 7 people total. So that means that means I have 7 people total, and I'm going to call that unit of measure total. And out of that, since the question wants to know how many do we expect to have a cold, we know out of the 7 people, 1 and 6, 6 of them have a cold and 1 of them has the flu. So since the question is asking about cold, we're going to worry about the 6. So that means out of 7 people total, 6 of them will have a cold. So this is the rate you're going to use to answer this question. You took the rate they gave us and you slightly modified it because of what they were asking and what they gave. They only gave us a total number. They did not give us a flu number or a cold number. They didn't give us either of those, so we couldn't use the very obvious rate they gave us. We had to slightly modify it. So we thought of it as a typical fraction. There's 1 piece, 6 pieces, so there's 7 pieces total, which means if you think of it 7 pieces total, of those 7 pieces, 6 of them have a cold. So this is the real rate you're going to use. So I'm going to erase the old one. So our proportion is going to look like this. We're going to say, okay, 6 people with a cold out of 7 people total. So your units of measure is, think of it as 6 cold over 7 total. It's okay if you just have 6 over 7 like this, but sometimes that's not clear enough for us to know what is the 6 and 7 referring to. So now are going to decide, okay, what's the other half of our proportion? The given information tells us out of 40 people total. So if the doctor sees 40 people, that means that's a total number. He saw 40 people. So that tells us, since total's on bottom here, we have to line up our units of measure. So total's going to be on the bottom over here. So 40 people total. That is not how you spell total. Now up top, we don't know how many have a cold, so I'll just make it a variable. I'll choose X. You can use whatever letter you want. Does not matter. All right, so let's see. Cross product property. Multiply diagonal this way. By the way, if now you've checked your proportion, hit pause for a moment. Make sure you can solve this on your own first. Take the time to make sure you can prove it. All right, so let's see. Multiply that direction first. So that's going to give us X times 7. Then multiply the other direction. So 6 times 40. Remember, those two things multiplied will always be equal to each other. So on the left side, x times 7, that's 7x. Don't overthink it. 6 times 40. Well, we know 6 times 4 is 24, so just put a 0 on the end of it. So that means 240. So 240, drop down your equal sign. Now, to answer this, your job is you got to now divide both sides by 7 to get x by itself. So we have a video talking about the cross product property if you need more help with this. I wrote divided by x. That makes no sense. We are moving 7, not the x. So divide by 7, they cancel on the left. So we're left with x equals, now let's see. To see what 240 divided by 7 is, we're going to bust out the long division real fast. So 240 divided by 7. 7 goes into 2, 0 times. 7 goes into 24, 3 times. 3 times 7 is 21. Subtract that, we get a 3. The decimal's there, by the way, so it's there. Bring down the 0. 7 goes into 30 4 times. 4 times 7 is 28. Get 2, drop down another 0, that's out here. 7 goes into 20 twice, and at that point I'm not going to keep going because we're talking people. So we can't have 0.2 of a person. That doesn't make sense. So we'll go ahead and just round, and we'll just say, we'll call it, since you can't have 0.2 of a person, we'll go round to the nearest whole person. The nearest whole person is 34 people, so I'm going to say, I'll put it approximately equals 34.2. But more specifically, that tells us that this doctor is going to, we can expect him out of those 40 patients, approximately, this is the symbol for approximately, it's a squiggle equal sign, 34 patients with a cold. That's going to be our answer. With a cold. And that's going to be the answer to this question. Let's move on to another one. Alright, so in this example, we're talking about life sciences. For every left-handed person, there are about 4 right-handed people. If there are 30 students in the class, predict the number of students who are right-handed. So now, that tells us this one's going to be just like the last one, where the rate they gave us, so one lefty for every 4 righties, that's lefty and righty are units of measure, but look what they gave us. They gave us a total number again. So we're going to have to do the same thing, where we're going to convert our rate to a total rate. So it says for every lefty, we know we have 4 righties. Now I'm kind of abbreviating it so it's easier to talk about. So for every lefty, so for every 1 lefty, I'll just use L, we have 4 righties. So now that tells us that we know if we were given any of this information, how many left-handed people or right-handed people, we'd be able to have a proportion ready to go. But what they gave us was, if there are 30 students in a class, they gave us a total number. So just like the last one, we need to know totals. So we have 1 person here, 4 people here, so that's going to be 5 people total. So 5 people total is what we're talking about. Now, out of that 5 people, the question wants to know who are right-handed. We know out of the 1 and 4 people, out of the 1 lefty, 4 right, the number of 5 people total that are right-handed are 4. So I'm going to call that 4 righties. So this is the rate we're going to use. Sorry for that interruption. So that means out of 5 people, 4 of them will be right-handed. So that's the rate we're going to use to solve this. Hopefully you already hit pause to get this one a shot on your own first. So that tells us we know there's 30 people total in the class. We have total on bottom. Therefore over here our total must still be on bottom. So 30 people total. I'm only writing these units of measure to help you remember how to line things up. It is okay if you very quickly just said, okay, 4 over 5 equals x over 30. That is technically fine, but make sure you know 4 what, 5 what, 30 what. Knowing the units of measures helps you stay organized. Now, just for the sake of using a different letter, I'm going to call this R for righties. That's what we're going to solve for. So we're going to multiply cross product property, 5 times R. So 5 times R, multiply in the other direction, same process as always, 4 times 30, and those will always be equal to each other. So now make sure you can solve. 5 times R, don't overthink it, 5R. 4 times 30, well 4 times 3 is 12, put the 0 on the end of it, so 120 is what that equals. We have 5R equals 120. Now divide both sides by 5 to get rid of that. Cancels. We're left with R equals 5 goes into 12. 5 goes in, or 10 goes into 120 12 times, but since 5 is half of 10, 5 does it twice as many times. So it's going to be 24. So 5 is going to go into 12 24 times. And that's going to be your final answer to this question. Now, again, I'm going to remind you one more time. For this one, you didn't have as much options in how you wrote the proportion because we had to convert the rate we wanted to use. We had to convert it to a rate where it's out of the total, not necessarily comparing left to right. So this one, you didn't quite have as much flexibility to write it, but that's okay. But it's still solved using the cross product property. So the last two examples, we had to take the rate they gave us, we had to slightly change it to a slightly different rate to make it more easily to interpret. All right, so let's move on to a different example. This will be our last example we'll do. And now, before we do anything, hit pause and see if you can do it on your own. See if you can come up with the proportion that you will need to solve it. So these will be the two that we will solve. So press pause now. All right, so hopefully you better hit pause and try out at least the two proportions, because this is two questions, so you should have two separate proportions. All right, let's read the question. It says, we're all talking about traveling. A speed limit of 100 kilometers per hour, otherwise known as kph, is approximately equal to 62 miles per hour, otherwise known as mph. Predict the following measures and round your answers to the nearest whole number. All right, question A says a speed limit in miles per hour for a speed limit of 75 miles per hour. I meant kilometers per hour. That clearly says kilometers. So now what we're going to do is we're going to use the original number they gave us. They told us 100 kilometers per hour is approximately equal to 62 miles per hour. That right there was our rate. They tell us 100 kilometers per hour is corresponding to 62 miles per hour. That's a rate. That rate is literally going to be half of the two questions we're going to answer. We're going to make that our proportions that we set up. That right there is going to be half of both of them. So I'm going to go ahead and write it down here already for option B. It says something for something. It doesn't even matter. It's a proportion comparing miles per hour and kilometers per hour. So that same rate is going to be the first half of the proportion down there. So hopefully I didn't skip ahead and cheat you out of realizing that on your own first, but it's going to be the same thing. So now, let's see if we can finish the rest of it. The question says a speed limit in miles per hour for a speed limit of 75 kilometers per hour. So they gave us the kilometers per hour. We chose to put kilometers per hour on top. So that means on the other side, we must also keep kilometers per hour on top. So 75 kilometers per hour is going to go on top over here. So 75 kilometers per hour over. We don't know how many miles per hour. That's the whole point. We got to look for it. So we'll call it X. Now, on the proportion down here, we'll start off just by writing both of them. Now, it told us a speed limit in kilometers per hour, so they're looking for kilometers per hour, for a speed limit of 20 miles per hour. They gave us the miles per hour. We chose to put miles per hour on bottom, so we have to keep it on bottom. Remember, we chose, you could always have these both flipped, as long as you do it consistently. So 20 miles per hour goes on the bottom. We don't know the kilometers per hour. I'll call it Y. Just use different letters. Solve both of these proportions and you'll have the answers to both of these questions. So we'll kind of do them side by side, do them at the same time. Cross product property tells us multiply diagonally. So 62 times 75. You don't have to go in the direction. I just always choose this direction because I'm right-handed, but it really doesn't matter. You could have gone in the other direction first. It does not make it. It does not change your answer. So down here, that's going to be 62 times y. Now let's go in the other direction. Up here, it's x times 100. X times 100. And down here, it's 100 times 20. Now, those will always be equal to each other, so do not forget your equal sign. All you do now is solve both of these equations. X times 100, that one's easy, 100x. 62 times y, that one's easy, 62y. Sorry, I keep bouncing back and forth. I'm just showing you the process is exactly the same. Bring down that equal sign. So now it's time to actually do some work. 100 times 20. Well, we know 1 times 2 is 2. We got 3 zeros total, so we're going to have a 2 with 3 zeros behind it. And so that's going to give us 2,000. So 2,000. Up here, 62 times 75. Let's bust out some long multiplication real fast to figure that out. 62 times 75. 5 times 2 is 10. 5 times 6 is 30. Plus 1 is 31. Drop a 0. 7 times 2 is 14. Put a 1 up there. 7 times 6 is, 6 times 6 is 36. So add 6 to that, we're at 42. Plus 1, we're at 43. Add those together, 0, 5, 6, 4. So 4,650. That's what that one's going to give us. So 4,650. Now, to solve this proportion, we have a one-step equation we now have to solve. We have to get x by itself, meaning we have to divide by 100. Same process as always. Divide by 100, those cancel. Now, dividing by 100 is easy. You literally just move the decimal place. We learned that back in chapter 0. So we're left with x over there. Now over here, we divide by 100. Remember, you take the decimal and you make it smaller. So to make it smaller, we had to go left. So that tells us 46.5. Now, they told us to round to the nearest whole number. So if we have 46.5, that's going to round up to 47. So that tells us 47. And because we were looking for miles per hour, it's going to be 47 miles per hour. And that's going to be your final answer for question A, 47 miles per hour. So now let's finish up question B and we'll be all done. Divide both sides by 62. I purposely bounced back and forth between those two questions to show you the process is the same. We go through the same steps to solve it. What was the key was the numbers were slightly different. So those cancel. We're left with y equals. Well, now we're like, well, hey, what is 2,000 divided by 62? This is your opportunity to maybe use long division one more time. Then we'll be home free. Now, for the sake of time, I know that I tell you not to do this and rely on it, but because this video is already 36 minutes long, I went ahead and just use the calculator. Now, to multiply those out, to divide those, you're going to get 32.25. Because it's 32.25 and instead round to the nearest whole number, we're going to round down to 32. And we were looking for kilometers per hour. That's what the question told us, and that's what our proportion says. So 32 kilometers per hour. So I'm not cheating. I just, for the sake of time, I've already had you guys for 36 minutes. So thank you if you stuck in there and you tried out all these questions. So one last recap. When you write proportions for rate problems, you're going to line up your units of measure because you'll almost always have different units of measure because a rate by definition is two different quantities of different units being compared to each other. So as long as you line up your units per measure consistently on the left side and on the right side, you are good to go. Good luck, guys, and I hope this helps you with one form of writing